So, good evening to one and all. So, today we're talking about second year physics, that is wave motion. So, wave motion. So, in the wave motion, everybody is struggling. So, everybody is struggling to derive an equation for the speed of transversal wave. So, everybody is struggling to find out derivation of speed of transversal waves. So, transversal wave, speed of transversal wave. So everybody is struggling. So in the wave motion second year physics first chapter this one. So everybody is struggling to find out the derivation of speed of transversal wave or speed of progressive transversal wave. So we want to derive this equation. So v is equal to root of t by mu. So I want to derive this equation. So v is equal to root of t by mu. I want to derive these equations. So we want to derive this equation. First we learn about what is meant by mu. First I want to learn about what is meant by mu. So mu is nothing but linear mass density. So linear mass density. So linear mass density mu. So what is meant by linear mass density, guys? So mass per unit length. So mass per unit length. Mass per unit length is called as mass per unit length is called as linear mass density. Linear mass density. Linear mass density. Linear mass density. So what is meant by linear mass density? Mass per unit length is called as linear mass density. So the formula is that mu is equal to mass by length. Mu is equal to mass by length, which is equal to small m by small m. So this is the formula for linear mass density. And also find out the units for this. So units of this, so always telling about in physics, the people are struggling because they don't know about units of that. That is the main general problem many people are facing. So first you know the in order. First you learn the definition, then go with the units. So in serious unit, centimeter. So that is the kg, no? So gram per centimeter. Otherwise, MKS or SI unit, MKS or SI unit, kg per meter, kg per meter. So gram per centimeter, kg per meter. Dimension formula for this. So I want to find out the dimension formula. So m power 1, so L power minus 1, t power 0. That is the dimension formula. So m power 1, L power minus 1, t power 0 is the dimension formula for this. So I hope till now we understood it. So what is the linear mass density? Mu is equal to mass per unit length is called as linear mass density. So linear mass density. And for deriving this equation, we want to know about certain things. So I want to know about certain things. What are the certain things? So let's see one by one. So we know that suppose let us say this is the arc. So this is R, this is R, and the angle made here is theta, and this arc length is L. So I want to find out the length of a arc. So generally when the length of an arc in radians, generally what is the formula? So theta by 360 degrees into 2 pi r. So 2 pi r means capital R here. So this is in degrees. In the radians, what is the formula for this? In the radians. So r theta. So keep in mind, guys, r theta. So L is the length of the arc, r is the radius of that circle, and theta is the angle made in between the circle. So that is the relation between L is equal to r theta. Keep in mind. So second thing is that we want a compound resolution. So we know already generally, let us say, so T is forcing acting on that. T is the force acting on this area, and angle made by this one is theta. Now I want how much force experienced on x-axis along horizontal. So what is the force here? T cos theta. So next one is what guys? So vertical force how much? T sin theta. So T sin theta. So this is the preliminary thing to request. And generally in circular motion, when you are talking about circular motion, so there is a force is acting toward the center, away the center. Two forces are acting toward the center, away the center. So centrifugal force and centripetal force. So centrifugal force, that is equal to F is equal to m square by r. So two forces are acting in both different directions and equal magnitude. That is F is equal to m square by r. F is equal to m square by r. Force is acting on that. So till now what we discussed guys, we talking about first one linear mass density, second one talking about how to find out the arc length, third one we talking about compound resolutions for vector, and finally we are talking about centripetal force and centrifugal force. What is centripetal force is equal to m square by r. So this is the basic things we want to derive speed of a transversal wave. I want to find out the speed of a transversal wave. V is equal to root of t by mu. That will get like this. So let's see guys here now the derivation. Go with the derivation. Let's see guys here now. So I want to derive this one. First what we have to do? We have to take a thread. I am applying the force on the thread. It will form a crust. No doubt. It will form a crust. And let alone this guys. Now it is like a circle. It forms a circle, no doubt. So let us say this is origin for this. So center of the circle, and I want to find this is R value. So this is also what guys R. So radius of the circle. Assume this is 2 theta. 2 theta. This is the 2 theta. And from here to here, the element length dl. So what is dl stand? So dl is equal to element length, element length. So dl is equal to element length. So element length. So this entire value is dl. Now we know that guys. We know that generally on string in this direction, what is acting on that? Tension force T acting on that. In this direction, how much is acting, guys? So tension force T is acting on that. So in this direction, T is acting. In this direction, I want to find out the direction of this. We go with the tangent. I draw a tangent over here. I draw a tangent between that. So I want to draw a tangent between that. Now we have to adjust this one with help of this. So let adjust that. So I draw a tangent. So this is what? 2 theta. So 2 theta. So this is what guys? dl. dl is element length. Now I want to find out. So I make a perpendicular bisector. Now I make a perpendicular bisector. So this is the perpendicular bisector. So now this become what guys? Pi by 2. This become 90 minus theta. This become what here? Agree or not? Why? Because this is 90. So this is 90 minus theta. So this value become 90 minus theta. This become 90. Why? Because the center become 90 only. So this is perpendicular. Na? So this is a perpendicular bisector. So this is become a theta now. This also become what here? Theta. So this is also become what? Theta. Now from compound resolution, so this become what? T cos theta. So this become what here? So this become what? So T sin theta. So this become what here? T sin theta. So this is T sin theta. This is T sin theta. In the same directions. So actually, when you are applying, we take a string. When you are applying a deforming force, So automatically in opposite directions, what will happen? There is a restoring force applied on that. So what is the restoring force here? So Fr. So F suffix R is equal to restoring force. The combined of T sin theta and T sin theta. S are not agreeable. T sin theta plus T sin theta. So why? Because we know parallelogram law vector. So same direction. Theta become what you will get 0. Same direction 0 in same direction. Theta is equal to 0. What you get? Sum of those two forces. What are the forces here? T sin theta plus T sin theta. So what you get, guys? 2T sin theta. So 2T sin theta. So we know generally for smaller angle, sin theta become what? Theta. Keep in mind. So very very important. Sin theta become for smaller angle. Sin theta become what? Theta. Tan theta become what? Theta. Cos theta become what? 1. For what? Smaller angles. For theta is very small. For smaller angles, sin theta become theta. Tan theta become what? Theta. Cos theta become what here? 1. For smaller angles. So according to that logic, now T into 2 theta. What is this is? Fr. So Fr. So everybody is struggling. Derive the equation for speed of transversal wave. So now we have a conclusion over here. I hope you people are understood. Now let's see, guys, here. Now I want to find out. Now I want to find out the arc value. What is the arc length? DL I want to calculate. So DL is equal to. So DL I want to calculate. Just now we have to see when I started my journey for getting the value of V is equal to root of 2 by mu. So I tell you arc in the radians r theta. So r into what is theta value, guys, here? 2 theta. Keep in mind 2 theta. So r into 2 theta. So I want 2 theta. So 2 theta is equal to dl by r. So 2 theta is equal to dl by r. So 2 theta is equal to dl by r we are getting. So next one, I want to find out the linear density, linear mass density. So linear mass density mu I want to calculate. So for what? For this dm particle. So for elemental length, what is the mass of elemental length? Dm is the mass of elemental length. So mu is equal to dm by dl. So from this dm is equal to, so mu is equal to dm by dl. So dm is equal to what, guys? So dm by mu. So dm by mu. Understood? I hope you people. So dm by mu. So keep in another one. So next one, from Fr is equal to T is okay. T into what is 2 theta value here? dl by r from this. So dl by r from this, Fr is equal to T into dl by r. But what is dl? What is dl here? What is dl here? dm by mu. So dl is equal to dm by mu. So dm by mu. So this is entire what? Restoring force. That is equal to equation 1. So I hope you people are understood till now. You don't confuse. We don't confuse, I hope. So Fr is equal to T by R into dm by mu. So observe here, the downward force is Fr. So restoring force. Downward force is restoring force. In upward, a centrifugal force acting on that. Centripetal force or centrifugal force. So I want to find out the that force, that is called F, assume. So what is that? dm e square by r. Agree or not? Just now I told centrifugal force or centrifugal force both are same. Equal and opposite directions will be applied on that, on circular motion. So let us say this is equation 2. Now what will happen, guys? So from this 1 is equal to 2. Equal and opposite directions. 1 is equal to 2. Now what will happen? So what is this one? T by R dm by mu is equal to dm into v square by r. So now dm cancel, r cancel. So v square is equal to t by mu. So finally v is equal to root of t by mu. I hope you people are understood. So everybody is struggling to find out the derivation of speed of a transversal wave exclusively in second year first chapter itself. Everybody is struggling. So this is the way we have to get the solution for this. So let's see applications of this one. Applications. I go with one of the applications. Let's see guys, see a simple applications of this. So let's say the first application. What is the first application of this? What are the first applications? So let's see the first application. So application one. So there is so many applications today we are discussing about one or more applications. So what is the formula guys? V is equal to root of T by mu. So what is density? What is density formula here? Density is equal to mass by volume. Everybody knows. Mass is equal to what is volume? Volume means area into length. So 1 by A into M by L. Agree or not? Is equal to rho. So rho is equal to 1 by A into mu. So in the place of mu, what we have to return? Rho A. So in the place of mu, that is linear mass density, what you have to substitute? Rho A. Now we have to substitute V is equal to root of T by what is that? Rho A. Rho A. So mu is equal to rho A. Agree or not, you people? I hope you people are understood. Next, application 2. So application 2. So what is the applications? We know stress. What is meant by stress? Stress we know. Stress is equal to force by area. Tension is also a force. Tension also force. From this, so this is equal to T by A, nothing but. So root of 1 by rho into T by A. So T by A what can I write? Stress can I write. Sometimes we got a stress also. Stress by rho. Sometimes we are given stress and we have to find out velocity of transversal wave. V is equal to root of stress by rho. I hope people are understood now. So let's see third applications. So let's see guys, application 3. So M3. So let's see guys, M3. Suppose a thread is there, you have to put this thread to a pulley which is holding over there, and it is down a block of mass M. So now we are applying what guys, we are getting a pressure thrust here. Agree or not? Agree or not? So now how much force is this is from this point, what force is acting? That is tension force T. And from downward what force is acting? Mg. Now what you get guys from this? So from this, so V is equal to root of what is T? T is equal to what? Mg. So from the place of T, what you have to put? Mg by mu. So another very important application. Sometimes we want to give an Young's modulus. Sometimes it will get a Young's modulus. So let us say application 4. Sometimes you get a Young's modulus. Sometimes you get a Young's modulus. So we know Young's modulus. What is meant by Young's modulus of a string? Y is equal to Young's modulus. So Young's modulus elasticity of a string. So F by A by delta L by L. You are writing this, what you get? So F by A into L by delta L. I hope you understood. We know from DL. So linear coefficient of expansion of solid alpha is equal to. So what do you get alpha? So delta L is equal to alpha L delta T. So what is delta T? Change in temperature. So T2 minus T1. I hope you get all the people. So from this, in the place of delta L, what you have to substitute? We substitute Young's modulus y is equal to F by A into L by delta L. So in the place of delta L, what you have to substitute? Alpha L dt. Alpha L dt. So L cancel. So what you get? F by A into 1 by alpha delta T. So I want F now. So F is equal to X modulus of A delta T. So we get this value or not? So Y means X modulus, A means area of cross section of a string, particular string, alpha is equal to linear coefficient of expansion of a solid, delta T is equal to change in temperature, nothing but higher temperature minus lower temperature. So I want to substitute in this formula. V is equal to stress. In the place of stress, we have to put guys. So what is that? What is the function? Y. So y a alpha delta t. Y. In the what is the force value? Y a alpha delta t by mu. So this is another very important formula. So this is the application of speed of a transversal wave. Thank you.